Charles' law states, at constant pressure, the volume of a given mass of an ideal gas increases or decreases by the same factor as its temperature increases or decreases. First, take a can. Put a teaspoon of water into the can. Then place the can into a pot onto the stove. Light the pot. When heated up, water and air molecules begin to move very fast, most going out of the can, although few remain into the can. They are moving so fast that they exert enough pressure to keep the can from being crushed by the outside pressure. Once you see water vapor coming out of the can, take the tongs and quickly turn the can upside down and place it into the ice water. When the can is placed into the water, the molecules cool, slowing down and condensing. When this happens, they do not exert enough pressure inside the can to exert the atmospheric pressure outside the can. The pressure inside and outside the can is no longer equal, and the greater pressure crushes the can.
V1 over T1 is equal to V2 over T2. V1 is equal to 0.325 liters, while T1 is equal to 273 degrees Kelvin. We do not know V2, so it's X, the variable. And T2 is equal to 373 degrees Kelvin. So you plug it into the equation, you get 0.325 over 273 is equal to X over 373. And you cross multiply and you get 0.325 times 373 is equal to 273 times X. And from there you multiply and you get 121.225 equals 273x. Yeah. From there you divide by 273 on both sides, and then you end up with 0.44 liters equals x, which is volume 2. Science. Okay.
Gay-Lussac's law states, at constant volume, the pressure of a given mass of an ideal gas increases or decreases by the same factor as its temperature increases or decreases. First, take 10 tablespoons of water and place it into a plate. Then place a candle into the middle of the plate. Remember, fire safety. Always keep something in case your hair catches on fire. Then place food coloring into the water. 3 drops should be enough. Mix the food coloring into the water until it turns the water the entire of that color. Then light the candle on fire using a lighter. Then place the glass upside down onto the candle. The candle should create a vacuum, sucking all the water into the glass.
P1 over T1 is equal to P2 over T2. P1 is equal to 0.986 atmosphere. And T1 is equal to 273 Kelvin. P2 is the variable, and T2 is 373 Kelvin. .986 atmosphere over 273 is equal to X over 373. You cross multiply and you get .986 times 373 is equal to 273x. You do some math and then you get 367.778 equals to 273x. From there you divide by 273 and you get 1.25 atmosphere equals x.
Boyle's law states that the product of the pressure and volume for a gas is a constant for a fixed amount of gas at a fixed temperature. For this experiment, you need a tiny balloon and a syringe. First, put the balloon into the syringe. Place your finger onto the open hole and pull up. As you pull up, the balloon expands. When you let go, it decreases again.
P1 times V1 equals P2 times V2. P1 is equal to 1.48 atmosphere. V1 equals to 0.01 liters. P2 equals 0.986 liters. And V2 equals X. 1.48 times 0.01 equals 0.986x. You multiply and you get 0.0148 equals 0.986x. You divide by 0.986x on both sides and you get 0.02 equals x. Woo! We did it.